distribution 1, distribution 2 device, access 1, access 2 device. And as you remember, the endpoint will always connect to the access layer switches. The endpoint will always connect to the access layer switches. And between access and distribution, we are using layer 2 network. Here, the connectivity is layer 2. All of these interfaces are configured as trunk. All of these interfaces are configured as trunk. But the connectivity between core and distribution is layer 3. We have configured IP addressing and routing protocol as well. So these interfaces are configured as layer 3 interface. And on this side, we are running routing protocols for the layer 3 reachability. Then we have tried to replicate the same design in data center network. We have tried to replicate the same design in data center network, but there was a lot of problems, right? Because if you look at this from the perspective of network, what does enterprise network serve? What do you think, guys? If we look at it from the operations perspective, what is the major difference between an enterprise network and a data center network?
Uh, in enterprise network, we follow the three-layer architecture, and the data center, uh, we follow the two-layer kind of spine and leaf architecture.
Okay, that's good, but I'm talking about the difference, like what does enterprise network gives us and what does a data center network gives us? What is the difference from operations perspective? So as you know that in enterprise network, what we have connected, in the enterprise network we have the end users, right?
Yes.
We have business applications, then we are offering internet access, then connectivity between branches. Let's say one branch is in Gurgaon, another branch is in Mumbai, so between branches or connectivity between branch offices, you can say cloud services. So the primary use of an enterprise network is to give access to the employees of the internet as well as the common resources, guest access, IoT devices, guest access and IoT devices. In enterprise network, we use protocols like VLAN for the segmentation. We use a spanning tree protocol. OSPF protocol is used. EIGRP protocol is there. BGP protocol is also configured. Then what kind of devices we use? We have access point, the wireless routers. We have switches, routers, firewall, firewall. Architecture is simple, three-tier architecture. Three-tier architecture is being used. That was the problem now, because in the initial days of it, we have tried to replicate the same design. The design which we use in enterprise network, we have tried to replicate that same design for data center network. But if you look at it from the user's perspective, what does a data center network is offering? Why do we have a data center network? As its name suggests. So guys, whenever you learn about data center network, and in the first class also we have discussed, data center network is built on three technologies: server, sorry, you can say compute,
Network storage.
storage, and network. What does a data center offer? In the data center network, who is the users? Not the end machines. Who is using the data center networks? We have servers, we have virtual machines, we have storage, systems. So mainly in enterprise network, as a human being, we are utilizing the network. We are using the network. But in case of data center network is not used by human directly. In the data center network, we're going to place servers, virtual machines, storage appliances, and all. Right? Our focus is on what? Design focus in data center network. Design focus is on high bandwidth because bandwidth play a very important role. Scalability. If you just trying to access Instagram, guys, let's say when you try to access the Instagram, you see that the Instagram application is taking a few seconds to load the content. And when you switch from one screen to another, from one reel to another reel, if it takes 2 to 3 seconds, how would be the experience? Now you see that people keep scrolling for hours, right? And they don't feel any kind of latency. But how does this network is working? Millions of people, right? They are on Instagram at the moment. They're trying to access their account. They're watching reels, scrolling through social media, right? But you see, there's no delay between one reel and another reel. Just you keep scrolling and you'll keep getting the useless content. But still, if you look at it from the technology perspective, how they have designed their data center network, you can imagine the bandwidth, right? How fast they are forwarding the traffic. So in case of data center network, our design focus is on high bandwidth and scalability. What is the architecture here? So now initially we were using the same architecture, but now we have changed it. And in data center network, we are using spine and leaf architecture. We are using spine and leaf architecture. Protocols, yes, we have protocols like OSPF and all, but we have new protocols as well. We are using VXLAN, Ethernet VPN, BGP, ISIS, OSPF. All these protocols are used in data center network. If you look at it from a device perspective, so we have Nexus switches here. We have Nexus switches. They are high performance switches. They are high performance switches.
Sir, one question. In implementation standpoint, uh, currently we are still using the ISIS in the data center network.
Yes. But
Oh,
when we
is it?
configure the data center network manually, we try to avoid ISIS. But once we'll discuss about ACI, application centric infrastructure, I'll show you that I will discuss about it. ISIS is automatically deployed by the ACI solution on your leaf and spine switches. And what does ISIS is doing in the data center network? We'll also be having this discussion. Okay,
Okay.
what is the agenda of ISIS? But it's still used, and it stands for intermediate system to intermediate system. It stands for intermediate system to intermediate system. ISIS.
Yeah. Will you be providing the basic background of the ISIS during that class?
I'm really sorry, but we'll not be having the discussion of ISIS actually. Okay.
Yeah. Okay.
Yeah.
So basically, I'm also not aware of this protocol ISIS.
If you're gonna deploy ACI, you don't have to have the knowledge of ISIS because it's automatically configured by the Cisco APIC controller, and it is even mentioned by Cisco that you're not supposed to have the knowledge of ISIS if you're deploying ACI. Okay, it is automatically deployed. So that's
Okay.
why,
Okay.
guys.
ACI is basically for fiber channel, you mean to say?
No, at this moment, let's not talk about ACI. We'll discuss about it. But right now, our agenda is to discuss about VXLAN and all. But yes, in the upcoming classes, we'll have the ACI solution as well. And at that time, we'll discuss what is ACI, how ISIS is deployed, why do we need ISIS in data center network and all. So if you have any question related to this part, please feel free to ask. Is it clear? Now
Okay,
we
sir. Please go ahead.
we can't replicate the same design in data center network. That's why we have a new architecture which is known as two-tier architecture, and in this two-tier architecture we have two layers of switches known as spine and leaf. So the spine 20120 is not a specific name, okay, just a reference here, or you can have then leaf 101, leaf 102. So we have leaf switches and we have spine switches. As we have discussed in the last class, that the rule is very simple. The rule is very simple. Spine switches
Should not
are
connect to the spine
allowed to
switch.
connect to
Leaves.
leaf, and leaf are allowed to connect to spine. But spine to spine and leaf to leaf connectivity is not allowed.
Yeah.
And the endpoint will always connect to the leaf. Endpoint means the servers. Okay. The server can be like this, guys, or you can have a scenario in which a server is connected, but inside this server we have what? We have hypervisor. After this hypervisor, we have a vSwitch, and then we have the virtual machines. So the virtual machines are not directly connected to the switches in this case, right? They are part of a server, so they are present inside a server, and that server is connected to the leaf switches. So in this case, we have the virtual machines. First, they'll connect to the vSwitch. Then we have the hypervisor. This is the physical interface of the server which is connected to the leaf 102. So you might have a server uh, dedicated for one service, or you might have a server having multiple virtual machines, or having multiple virtual machines. Okay. So first, spine to leaf and leaf to spine connectivity is allowed. This spine and leaf switches are having layer 3 connectivity with each other. So there's no layer 2, guys. There's no layer 2 between leaf and spine. It's all layer 3 environment. STP is not required, and we can achieve ECMP also. So now in this case, spanning tree protocol is not required in your spine and leaf architecture. And we are running layer 3. Because of that, I would be able to use routing protocols, and we can achieve equal cost multipath. We can achieve equal cost multipath. Then, as I gave you an introduction in the last class also, in this case, we have symmetrical topology or symmetrical connectivity. So wherever you go from one leaf to another leaf, you'll always at the same distance, because there is no possibilities to go traffic from leaf 101, spine 201, then spine 202, then leaf. So the path is always, the traffic is always going to take a predictable path. The predictable path is always from leaf, spine, and leaf. leaf, spine, and leaf. Then we have benefit of horizontal scalability. This thing is similar to our enterprise network also. Let's say if I want to add more leaf switches, I can add more leaf switches without disturbing the whole design or without disturbing the whole topology. And in case if we feel that our spine switches are overloaded, so we can simply add spine switches as well. We can simply add spine switches as well. So that's the benefit of using it.
If we add one more spine switches, uh, how do we add over here in this scenario?
Sorry. If you
If we
add
need
one
to
more,
add, uh,
so you can simply connect your leaf switches to that spine.
okay, so let's see if we have multiple internet or some MPLS connection, uh, then that switch doesn't connect to the internet or the MPLS directly, right?
MPLS, that's
Servers.
layer 3 connectivity to the external world, and we connect it to the leaf switches most of the time. Okay, we
Yeah,
connect it to
anyway,
the leaf switches.
yeah, moving forward, we'll get a good understanding.
Okay, so these are the benefits of using this leaf spine and leaf architecture. That it's very simplified topology, layer 3 between leaf and spine. But now the problem will also be there, so we have to make the concept of underlay and overlay in this design. Because now, what if the machine sends a layer 2 frame, and I want to send this layer 2 frame from leaf 101 to leaf 0102, but the problem is the network between leaf 101 and 201 is layer 3, so I cannot forward a layer 2 frame directly over a layer 3 network. That's why we will be having the VXLAN encapsulation. We'll come to that part, but before that, this is our spine and leaf architecture. Then in data center network, guys, we have type of traffic flows. Type of traffic flows, you might have heard of it, but no worries if don't know about anything about this. We'll be having the discussion from scratch. So we have east to west traffic and north to south traffic. North to south traffic. Traffic pattern in a data center network. Okay. So we have type of traffic known as north to. We also have east to west traffic. North to south traffic and east to west traffic. And there's a reason that why we need VXLAN in our data center network. And the reason is east to west traffic. The reason is east to west traffic. So let's get an image here. This diagram is not clear, guys. Okay, so let's use this topology. It is more clear as compared to the previous one. So here, understand, this is a data center network. Let's say uh, this is you. Okay, you are connected to your home Wi-Fi. This is your home Wi-Fi router, home Wi-Fi, and the wireless connectivity is there. And this is Instagram account. So from this home Wi-Fi, you'll go to the internet, and somehow through the internet, you will enter in this Instagram data center. But what do you think? You'll directly land on the server? No, you'll not directly land on the server. First, you'll be going to their routers in the network. Then they'll forward traffic to the switches. After the switches, we have load balancer also in data center network, guys. In data center network, we have load balancer as well. And what does this load balancer will do? This load balancer will distribute the load among the servers. So this type of traffic, as per the direction of this, let's say if we talk about map of India, right? So we have south part of India, north, east, west. Likewise, here we have traffic which is going from north to south. It means that this there's a client who is trying to access the server. So traffic will go like this. This is not the exact pattern here because we will be having appliances in between. Let's say I'll be having a firewall because I can't allow someone to directly go to my servers. And with the firewall, we'll also have a load balancer. So as an user, we always hit on the load balancer, and then load balancer will decide where should I forward this packet. This packet should be forwarded to this server, or this server. That is the responsibility of this load balancer. In the early days of data center network, this was the traffic. Percentage of north to south traffic was more as compared to the east to west traffic. East to west traffic. So 80% of the traffic was going outside of the data center network. So request was received, traffic sent in case of north to south. So north to south traffic, simple, right? Traffic that enters or leaves the data center network. You might be thinking that topic of the day was VXLAN, but why do we have this discussion? Guys, this discussion is very important to understand VXLAN. If I just show you VXLAN directly, you'll be like, okay, VXLAN is something, but you'll not be able to understand the exact use cases of the VXLAN. So north to south traffic that enters or leaves the data center. Traffic that enter or leaves the data center is known as north to south traffic. If someone is trying to access the servers from outside, right, then we have traffic. Like I said, traffic is now going directly on the server. First, this is the client. This is the external client. Then traffic will come to the internet. Then the data center. Inside that data center, you have a firewall. After firewall, you have a load balancer. And then you reach the server. Then you reach the server. Or the traffic type can be HTTP, HTTPS, API calls, and all. API calls and all. Then we had no we have east to west traffic. As its name suggests, traffic that remain within the data center network. Within the data center network. You have server 1, server 2, server 3, server 4. Server 1, server 2, server 3, server 4. So we have this traffic, east to west traffic. In the past, most traffic was north to south, user accessing web servers, but today application talk to each other constantly also. That's why we have, you can say, dominance in east to west traffic also. In east to west traffic also. What might be the use cases of east to west traffic, guys? We understand that client will send the request to the server will give the response. Then why do we have this east to west traffic in data center network? Why does this server needs to communicate with each other?
Each rack we installed top of the rack switches, like leaf switches. So each switch want separate server. Each rack their separate server is there. Is correct?
No, that's correct, but I'm saying why do we need east to west traffic? Because servers are here to give the services to the users. Users will come from north side, access the server from south, so that's north to south traffic. But now we want east to west traffic also, from server 1 to server 2, server 3, server 4. Why does these servers needs to communicate with each other?
For load
Uh,
balancing. For one user, they want could not only a single server, they go to multiple server. We need to load balancing. Lot of traffic want to communicate with each other.
Okay, so first we have the concept of VM mobility here. We have the concept of VM mobility. Let's say on server 1 we have a virtual machine. But the problem is, if we'll keep that virtual machine to server 1 only, what if the server 1 is gone? Then I have to create a clone of this virtual machine on my second server also. Might be I'm creating a clone on third server also. So I need server to server communication. So what direction is this? This is east to west direction. This is east to west direction in data center network, right? Now I got cold, guys. Weather is changing, right? Then we have nowadays you will learn about it multi-tier applications. If you want to explore it, you guys can explore this part, multi-tier applications. But what do we have in these multi-tier applications? What they are trying to do, the application developers, the advanced parts. Web server is required. For an application, database server is required, and as well as to host the application they need an application server. So modern applications are built using a multi-tier architecture. And in that case, there's one application, but web services are on one server. Let's say I have an application, and for that application, web services are deployed on server 1. Database services are on server 2, and application is deployed on server 3. So to fully functional for this application, they need continuous communication with each other. That's also increase the east to west traffic. So in that case also we have east to west traffic a lot. Then you might have storage replication. Because we want to ensure high availability, and as well as want to make sure that we have data redundancy. So databases and storage system replicate data across multiple nodes inside the data center. Inside the data center. Then we have virtual mobility also. Load balancer and firewall communication as well. Because now you might have heard of this, we can have virtual server, virtual firewall and virtual load balancer. If even the load balancer and firewall are also deployed in a server as a virtual machine, so traffic first go to those servers inside the virtual machine, then firewall will inspect the data, then traffic go to other servers. So that's why in case of data center network, we have seen a increase in east to west traffic also. And in modern data center, about 70 to 80% of traffic is east to west, because the servers, databases and microservices are talking to each other all the time. All the time. Then you'll say, okay, makes sense that we have east to west traffic, we have north to south traffic. But our topic of the day is VXLAN. How does VXLAN fit in this situation? How does VXLAN fix in this situation? What is the use cases of VXLAN? Or why do we need it at all? So what VXLAN is going to do now? Again, as we have discussed here, let me copy our topology. Control C. Right. So now we have layer 2 and layer 3. Why does VXLAN is needed? That's the question. So now VXLAN will do what, guys? VXLAN will allow us to forward traffic from one server to another server, from one server to another server site. That was the main reason to use VXLAN here. That was the main reason to use VXLAN in data center networks. If there's a virtual machine and that virtual machine is trying to reach another virtual machine in the same subnet, this virtual machine will generate a layer 2 data. But the problem is, once this traffic will reach to leave 101, 101 will say, okay, let me learn the source MAC first. All right. Then leave 101 will say, okay, let me forward it. Leave 101 can forward this traffic to other interface if that virtual machine is located here. Because layer 2 traffic can be forwarded, received on this interface, forwarded to this interface. But the problem is, now I cannot forward a layer 2 frame directly on this side. You're also well aware of this. You're also
Yes.
well aware of this. So then why do we need the VXLAN here? What VXLAN will do, guys, if I just give you a quick idea of VXLAN. VXLAN will encapsulate your layer 2 traffic and layer 3 traffic. It can just provide us an overlay connectivity. It can provide us an overlay connectivity. So how the VXLAN will fix in data center network? Let's first see it here. VXLAN stands for Virtual Extensible Local Area Network. It is designed to offer an overlay technology to encapsulate layer 2 and layer 3 packets to add and forward between switches. But I'll not say that it is specifically designed for data center networks, but it is designed to provide the encapsulation. And you can compare it to GRE, guys. How many of you know about GRE, generic router encapsulation?
Yeah.
I
GRE
hope you,
tunnel.
right, you know about
Tunnel.
GRE tunnel. So GRE tunnel do what? GRE tunnel also forwarded traffic from one side to another side and gives us overlay. So now in case of GRE, your actual data is hidden inside the outer payload. Likewise, this VXLAN, or it is used to optimize the east to west traffic in data center networks, supported by switches. Of course, it needs to be supported, otherwise, how we'll configure it? Then VXLAN is a layer 7 protocol based on UDP. I will come to this discussion. And port number is 4789. This is the port number for VXLAN. This is the port number for VXLAN. But how VXLAN is going to encapsulate our payload? Then there are other advantages also of VXLAN, but first understand this, then we'll talk about there were some problems with the VLANs also, and the VLAN problem solved by VXLAN. Here, this is my leaf 1, this is my leaf 2, this is my spine 1, this is my spine 2. We have a server here and we have a server here. Now, if you have configured VXLAN, what VXLAN will do? VXLAN will configure an IP address on leaf switches, and that IP is known as VTAP. VXLAN tunnel endpoint. Okay, we'll discuss about it, guys. Don't worry at this moment. Just try to understand this. So VXLAN VTIP IP is 10.1.1.1, 10.1.1.2, and then IP address is also configured on leaf and spine switches. Now here, first of all, let's say in case of normal network, when you are doing everything manual, you can configure OSPF as a routing protocol, which will provide connectivity between leaf and spine switches. And if we have ACI, then in case of ACI, ISIS is deployed to build the underlay. I'm sure that you guys understand the difference between an underlay network and overlay network.
Yes.
So VXLAN is going to create what? VXLAN is going to create an overlay network. VXLAN is going to create an overlay network here. Underlay and overlay network. Okay, because otherwise we have to write it down a lot. But let's not waste time writing down this stuff. So we have an underlay network is the physical hardware based foundation of a network consisting of routers, switches, and cables which provide basic connectivity and transport data packets. And on top of it, we can build an overlay network. An overlay network is a virtual logical network built on top of underlay using technologies like VPN or SD-WAN to create logical communication path and add features. So using technologies like, let's replace it with VXLAN in our case, because we are using VXLAN, like VXLAN to create logical communication path, add features. So first we'll make sure that the VTIP addresses are reachable to each other. Then there's a host, and this host is sending layer 2 frame, let's say. So MAC address of this is A and MAC address of this is B, but we don't know the MAC address by default. So let's say I'm sending an ARP request. But the problem is, source MAC is A and destination MAC in an ARP request is F F F F F F F F F F F F. This frame is given to live. But as you know, guys, even if you compare it to a router, let's say this is a router. If a router has received an ARP request on this interface, what do you think, guys? Is this ARP request is going to be forwarded on the other interface?
No.
No, right? ARP is limited in a one broadcast domain, and a router receives a packet on its interface. Router can respond to an ARP request, router can generate an ARP request, but router will never forward an ARP request received on one interface, will never be forwarded to another interface. Will never be forwarded to another interface. Likewise, here the ARP request will not be forwarded further. But the problem is, if ARP request will not be forwarded, how I'll get the MAC address of it? And if the MAC address is not available, then communication will not be successful. So we have to forward this ARP, but it can't be forwarded over layer 3 network. Then who came as a savior? The VXLAN. What VXLAN will do? VXLAN will keep it as it is. No changes in this. This is on leaf 1, okay, or not on the spine. This is on leaf 1. So now VXLAN header will be added. We'll talk about it, what we have in the VXLAN header, what kind of properties we have in it. VXLAN header. VXLAN is based on UDP. A UDP header will be added. And after this UDP header, an outer IP header is added. Source IP is going to be 10.1.1 and destination IP will be 10.1.1.2. And then, guys, its underlying media is Ethernet. So you have to add a source MAC and destination MAC. Source MAC will be of the exit interface and destination MAC will be of the next stop. But you have to focus on VTIP IP addresses. Now traffic will go to spine. Spine will just look at the outer MAC header and outer IP header. And spine 1 will forward this traffic to leaf 2. And guys, what is the main one more advantage of this? The spine switch does not need to learn about the MAC addresses of each and every endpoint. You can have thousands of virtual machines, but this time the leaf don't care. Leaf doesn't know about your endpoints. It is just look at the outer IP header and outer MAC header, forward traffic to leaf 2 in this case. Now, leaf 2 is receiving this payload. Leaf 2 is receiving this payload. Okay, guys, let's move it here. Let's keep it here and then let's come back. So now the spine 1 will forward it to leaf 2. Leaf 2 will receive this payload. Oh my God. It is copied in the bottom. Okay. Leaf 2 will receive this payload. First, leaf 2 will say, okay, destination MAC is mine. It will check the destination IP address. Okay, destination IP also belongs to me. It means I have to process this data. Then it will open the UDP header. Then it will open the VXLAN header. After this VXLAN header, it will realize that there's one more Ethernet header, and the destination MAC address is not belongs to me. It is a broadcast MAC, so I have to forward it further. Then it will forward it towards the server 2 side, but only this payload. All other payload or data will be removed, but only this payload is forwarded to server 2, guys. And again, one more example of the servers or the end users being the king of a network, because everyone is working for them, but they don't even know about it. They don't know the offer VXLAN over layer 2 traffic, or like it can encapsulate layer 2 traffic also. But the Lisp locator ID separation protocol cannot encapsulate layer 2 traffic. Lisp only support, there's a protocol which is not our cup of tea at this moment, but it is known as locator ID separation protocol, Lisp. Lisp was also proposed as an overlay protocol here, but Lisp only encapsulate layer 3 traffic. It does not encapsulate layer 2. But in this case, in case of VXLAN, I want to extend my layer 2 traffic also. It makes sense, the basic idea of VXLAN here.
Okay.
Any challenge till now?
Okay. If we have uh, two more leaf switches in this network, so in that case, will we have additional two VTEP interfaces?
That is related to the configuration part. So at the time of the configuration, we'll discuss about it, how to make the configuration. Okay.
Hmm.
At that time, we'll see how to make the configuration, how to configure the VTIP addresses, and in order to create the VTIP, what kind of interfaces we need to create.
One more thing, in spine 2, we have written uh, the header information there. Over there, we have source MAC and a destination MAC, which we have written in the red format. So, red color. So, that source MAC address and the destination MAC address will be, uh,
This is of the
it will
interfaces.
be based on the layer 3 traffic. So it should be the next hop MAC address, right?
Yeah. The source MAC is the exit interface MAC, and destination MAC is the next hop MAC.
Okay. Sure.
All right. So here we have this VXLAN now, and this VXLAN will provide us an overlay technology. This was the main use cases of the VXLAN, but VXLAN also gives us segmentation options as well. Because in case of normal enterprise network, for the isolation of the traffic, we use something known as VLAN, virtual local area network. What's the range of VLANs, guys?
4094.
Right? VLAN is a 12 bits long value. Range is 0 to 4095. Usable VLANs are from 1 to 4094. You can't have 0 and 4095 in use, but we can use 1 to 4094. But what VXLAN is using here? VXLAN is using something known as VNI. VXLAN is using VNI. Okay, and the range of the VNI is, guys, 24 bits. The range of the VNI is 24 bit. And if you'll go 2 to power 24, VXLAN network identifier. So this is a 24 bits long value. 24 bits long value. It can gives us 16 million segments, because 2 to power 24 is 16 millions carried inside the VXLAN header. Carried inside the VXLAN header. But it's not that VLAN is obsoleted. We still have the VLANs, but the significance of VLAN is limited to the leaf switches only. Beyond a leaf switch, the VLAN has no significance, and we always bind the VLAN with VNI, because if you look at this from our topology perspective, this is a virtual machine. So guys, if you have ever worked on vSwitch, you know that on vSwitch we create virtual interfaces, and those virtual interfaces are assigned to VLANs, right? So this VLAN, this virtual machine is in VLAN 10, this is in VLAN 20, this is in VLAN 30, let's say this is VLAN 40. So once they forward the traffic to the leaf switch, they will be coming with a VLAN ID. They don't have the VXLAN, or they don't have the VN ID directly. So that's why on the leaf switches, what we do, we create mapping VLAN to VNI. We'll discuss about it, that what is the relation between VLAN and VNI. But first, now the VXLAN gives us segmentation, and we can have 16 million segments in case of VXLAN, virtual, VXLAN network identified. So VXLAN is also solving the problem of the VLAN limitations. It is also solving the problem of the VLAN limitations. We're not going to face this problem anymore, because we can have 16 million subnets now. We can have 16 million subnets now.
So, but still we can create only 124094 VLANs in that network. So how we will be utilize more than that VLANs with the help of this VXLAN?
Very good question, but the VLAN is just limited to one leaf. So on the other leaf, you can use the same VLAN range. You don't have to use unique VLAN IDs across the entire network. Same VLANs can be used multiple times. Okay.
Okay.
And at the time of the configuration, when we'll create the mapping, it will make more sense.
Okay.
Then on internet, there's a website where they upload the captures. Let's say VXLAN traffic capture. If you can see a Wireshark capture. Okay, there's an example. This is an example of a traffic, an ICMP packet encapsulated with VXLAN. This is an example from internet, guys, where they have uploaded the packet capture. So we have an ICMP packet here. This is an ICMP packet. originated on a virtual machine or a physical machine. Then they have added their source IP and destination IP. So source IP is 192.168.12.101. They've also added a destination IP 192.168.12.102. Then they also added source MAC and destination MAC. Now guys, if you would be using Lisp will remove this and only encapsulate IP and ICMP. But VXLAN can carry our layer 2 data as well. Then after that, you can notice that we have the VXLAN header. So this is the original payload. This is the original payload encapsulated with VXLAN. Then VXLAN is based on UDP, so UDP header will be added. And after UDP, you have added an outer IP header. Source IP 1.1.1, destination IP 239.1.1. This time it's a multicast packet, and multicast is supported in VXLAN. That's why we had discussion of multicasting also. And then outer source MAC and destination MAC. Outer source MAC and as well as the destination MAC. So if we open this packet, you notice that in the VXLAN, like I said, the VNID, VXLAN network identifier, is carried inside VXLAN. The VNID is carried inside the VXLAN. UDP source port is random, destination port is 4789. Uh, in our notes, port number is 4789 as we have noted here, right? Then IP header, source IP, destination IP, source MAC, destination MAC. So this payload is encapsulated. But there's one thing for sure, extra payload is going to be increased. There's gonna be extra payload. Because if you generate a packet, you just add ICMP, source IP, IP header and Ethernet header. But once VXLAN came into the picture, VXLAN will also add its own payload with the actual header. It will also add extra payload with the actual header. So what's the header length of VXLAN? 8 bytes. Now look here. There's an example of original layer 2 frame. This frame is received on the leaf switch. This is the original frame. This is the original data. After that, you have added a VXLAN header. So length of the VXLAN header is 8 bytes. VXLAN is based on UDP. So a UDP header is added. Length of the UDP header is 8 bytes. Then outer IP header is added and default length is 20 bytes. And for MAC header, usually the MAC headers, length is 14 bytes. But if there's a 4 bytes extra payload, which is for VLAN ID and all, .1q tagging, right? So it can go up to 18 bytes. So if we look at this, we will be adding 8 plus 8 plus 20 plus 18 bytes. So 20 plus 18, 38, 38 plus 8, 46, 46 plus 8, 54. Please check my calculation, guys. I'm not sure about this total, okay? But I think it's
Yes,
54, right?
sir.
So we have 54 bytes of extra payload always. But yes, we can do that because we have powerful switches and they're designed for this, guys. So we don't have to be, you can say, pity about this. Okay, why we are forcing this stuff on the switches? The switches are built for this. They're designed for this purpose. So they'll manage, they'll just keep adding this, because at the end of the day we have to forward the traffic, and we want is to west traffic to be treated very well without any latency. That's why we have to add this extra payload, and no worries, the switches will take care of it. The switches will take care of it. But that's how the VXLAN is going to encapsulate our payload. That's how the VXLAN is going to carry our payload. It makes sense till now, guys. Any challenge here?
That's still good.
And you see that the VXLAN header doesn't carry much information. In the VXLAN, we just have the VNID, which is 5012. 5012, and it's saying that there's a bit VXLAN network ID 1. It means that VNI is present. So this flag will inform the switch that VNI is present in this, and the VNI value is 5012. Now by default, VXLAN is not enabled. We have to enable the VXLAN feature. We have to enable VXLAN feature. And layer 3 encapsulation VXLAN. You can see that we have an example of layer 3 encapsulation in the Wireshark. Likewise, we can have layer 2 encapsulation and layer 3 encapsulation both. So our VXLAN can carry layer 2 traffic as well as layer 3 traffic. Here's an example. Let's say there's a host. The host is sending packet. VTIP means there's a switch. So source IP A, destination IP B, source MAC A, destination MAC B. Traffic given to the nearest leaf switch. On this leaf, we already have MAC and IP for this VTIP. So IP is 165.123.1.1. And in between, we have layer 3 network. This is the underlay. This is the underlay. So what we will do, guys, this was the actual payload. This was the original payload. But this switch will add VNID, UDP header, outer IP header. So in the outer IP header, we have IP1 as source and IP4 as a destination. Who has the IP4? This VTIP has the IP4. And then outer MAC and a source MAC and destination MAC. Traffic is given to the layer 3 network in between. This is the underlay. What they will do? They don't care about VXLAN at all. They'll just look at the outer IP header, and on the behalf of outer IP header, router 1 will give traffic to router 2. Router 2 will just look at the routing table, and it will give traffic to this leaf switch. And this leaf switch will receive it, and leaf switch will give it to host B. But if you notice, this switch will remove all extra payload, and only the original payload is given to host B. Only the original payload is given to host B. So that's how the VXLAN is going to encapsulate this whole traffic. That's how the VXLAN is going to encapsulate this traffic. Then we'll also have this discussion, right? Because if you have this topology, it seems very simple in this topology, but what if I have one more leaf 3, we have leaf 4 also, and they are connected to spine. They also have a VTP address, right? 10.1.1.3 and 10.1.1.4. How does this leaf 1 know that this B or host B is located behind leaf 2, or this host is located behind leaf 3, or this host is located behind leaf 4? So guys, in VXLAN also we have control plane part, and as well as we have data plane part. So first we'll discuss about the control plane, and we'll discuss about the data plane, like how the data plane traffic will work and how the control plane traffic will work. So first of all, how VXLAN will exchange the information with each other, how the VTIP IP addresses will be configured, VTIP reachability. Then when you forward the actual user traffic, how data plane traffic will be treated in VXLAN, or how does a leaf know about the location of the remote endpoint. So in VXLAN, we use these terms regarding the endpoints. We have two types of endpoints here, guys: local endpoint and remote endpoint. So let's say from a leaf 1 perspective, this server is remote endpoint and this is a local endpoint. So if you have one more server, let's say, connected to this, and the MAC is, let's say, C. So if source MAC is A, destination MAC is C, traffic will go to leaf 1 and leaf 1 will forward it to this. Because this time leaf 1, no, this is a local endpoint, and if it is a local endpoint, I do not need to encapsulate with VXLAN. If the endpoint is local, then we don't need to encapsulate it with VXLAN. The VXLAN encapsulation is only required if the endpoint is a remote endpoint. The endpoint is a remote endpoint. Only then this is required. Only then this is required. Make sense, guys?
Uh, okay, sir. How does the leaf switch aware of that the endpoint is locally connected, or it is on the other leaf switch? I'm talking about in terms of an ARP packet.
So now here, very good question, by the way. We had tables, guys, type of tables in our networks. What happened to it now? Sorry. Okay. So in normal networks, we have types of table, right? Switch maintains a MAC address table. Agree? Then switches maintain. If routing is configured, they also maintain ARP table. And then there's IP routing table also. IP routing table. Now, when you deploy the VXLAN, we have one more type of table which is known as what we call it?
Endpoint. Oh.
Endpoint table. So the information of the endpoints, local endpoints and the remote endpoint is stored in this endpoint table now. They are not inside the routing table, and in this endpoint table, you have the information of the VTIP also. So if you learn about a host, and for that host, if the remote endpoint, VTIP doesn't exist, it means it's a local endpoint. So whenever you learn about an endpoint directly to one of your interface, you will put it inside the endpoint table. But for this endpoint, there is no VTIP because it is directly connected to me. So there will be a keyword that this entry is local. This entry is local entry, or you can say the local endpoint. The local endpoint. And if there's a remote endpoint, then you will have a VTIP identifier. You will have a VTIP identifier for it. And again, once we start making the configuration, we'll see it, the endpoint information, and then local entry and as well as the remote endpoint entries. It is similar to a router. Let's say if you have a router R1 and R2, R1 has two interfaces, F0/0, F0/1. By default, the routing table is empty, right? In routing table, we don't have any entries. So this is the routing table. Once you'll configure IP address on this interface 10.1.1/24, and on this I have configured an IP address 12.1.1.1/30. What router will do? First thing router will do is router will install two entries in its routing table 10.1.1.0/24. Now tell me, these networks are local or remote?
Local.
Local, right? But if there's a network connected behind R2, let's say 20.1.1.0/24. Now the question is, how does R1 know about it? So in R1 we have, and between R1 and R2, let's say I've configured OSPF. So it will say 20's network is reachable via R3 and it's not a directly connected network. It is received by OSPF. Likewise in VXLAN, to learn about the local endpoint and remote endpoint, we always have methods. We have flood method, flood and learn. And then second option we have is BGP, EVPN. So to learn about local endpoints, we don't have to do anything. Once they forward the traffic, switch will learn about their entries, and the entries will be added in the endpoint table. But for remote endpoint, we have to see how we can learn about the remote endpoints. For that, we can use the flood and learn option, or we can use BGP EVPN. Make sense?
Yeah, now it makes sense. Thank you.
Okay. You're welcome. All right, guys. So this was a quick introduction to VXLAN. I hope you guys have enjoyed the session. Again, 1.5 hour is enough. So in the next class, we'll explore the configuration part, as well as we'll see the output of the configuration, and then we'll see the traffic forwarding. In the traffic forwarding, I'll show you how does the data plane works, what is flood and learn, what is the BGP EVPN concept, and how does they work. And then we also have the use cases of multicast here, as we have discussed about multicast, how the multicast is being used. Likewise, we'll see multicasting uses in our VXLAN environment also. Till now, if you have any challenge, please feel free to ask any question for me.
I'm good.
I hope you guys enjoyed the session throughout this 1.5 hour
Yeah, sure.
without getting bored.
Yes, sir. Sure, sure.
Okay, guys. Okay, then let's connect tomorrow, and
Okay,
we'll
sir.
see in
Thank
the
you.
next weekend. next week we have Diwali, guys. So we'll plan the leaves. Okay.
The entire next week will be leave or couple of days?
Sorry.
The entire next week will be leave or couple of days?
Not entire week. We'll have just on I think Diwali is on Monday, right?
Yeah.
Yeah. So we'll take off on Monday only.
Okay.
Okay, sir. Thank you, sir.
All right, guys. Have a good evening. Bye.
Okay.
Thank you.
Same to you. Bye.
All right.